Hello everyone, my name is Arpita and today I'll be presenting my industrial internship work at GSTN, which focused on two key projects, fraud detection model and a blog recommendation system. This internship provided me with invaluable experience in applying machine learning to real world challenges. For the fraud detection model, the motivation behind this project stems from the increasing volume of digital transactions and the inadequacy of traditional rule based fraud detection systems, which often suffer from high false positive rates. For this model, I implemented core machine learning algorithms from scratch using NumPy and Pandas, aiming for deep understanding for the underlying mathematics. For the blog recommendation system, the challenge here was the sheer volume of digital content, making it difficult for users to discover relevant information. Traditional keyword based approaches often fall short in providing personalized and context aware recommendations. My solution involved developing a scalable and modular system using React.js for the front end and Django for the back end, and using TF-IDF vectorization and cosine similarity to generate recommendations. The utility of the fraud detection model is twofold. Financially, it aims to reduce losses by accurately identifying complex and fraud patterns that often evade conventional methods. Operationally, it seeks to optimize risk management by significantly reducing both false positives and false negatives in fraud alerts, leading to more efficient resource allocation. The blog recommendation system offers significant utility. From a user experience perspective, it tackles information overload directly, enhancing engagement and content discovery by providing relevant, personalized suggestions. For platforms, it can increase overall content consumption and demonstrate a practical integration of machine learning within modern web application architectures. Now look at the methodology. For the fraud detection model, the process involved data acquisition and pre-processing, followed by the manual implementation of machine learning algorithms, and finally model training and evaluation. For the blog recommendation system, the methodology included data acquisition and pre-processing, then content-based filtering using TF-IDF and cosine similarity, followed by system architecture and implementation with React.js and Django, and qualitative analysis for evaluation was conducted after that. For the fraud detection model, it was observed that the support vector machine with a linear kernel consistently delivered the best performance across accuracy, precision, recall, and F1 score. Logistic regression and random forests also showed competitive results, particularly in recall and F1 score, which are crucial for fraud detection, where minimizing false negatives is important. The decision tree algorithm, however, demonstrated the weakest performance, indicating its limitations in capturing the subtleties of fraud patterns. This highlights the importance of selecting models that can effectively balance precision and recall to minimize both false positives and false negatives. Regarding the blog recommendation system, the combination of TF, IDF, and cosine similarity proved effective in generating recommendations that were semantically relevant and contextually aware. The React Django architecture facilitated seamless, real time suggestions, contributing to a smooth user experience and demonstrating system scalability. However, a notable limitation was observed in topic redundancy, where recommendations tended to cluster around similar themes, potentially limiting content diversity for the user. In summary, the key highlights of this internship include the deep technical understanding gained from implementing ML algorithms from scratch, the development of seamless real-time content discovery engine for the blog recommendation system, and the successful integration of machine learning solutions into practical real-world applications. These projects collectively showcase proficiency across diverse technologies from core Python libraries and advanced NLP to web frameworks and cloud environments. Here, in the next video, I'll present the working web application for the blog recommendation system. This is the register page of the application system. Here we can register as a user. Now this is the login page. Login as a registered user. This is the landing page after the login. Here are various features like home, create post, logout and change password. Now I'm creating a new post as a user. Now go to home, open Imagica the Wonder Park or any other blog. You can check the recommendations below the blog with the similarity score written beside it. Here you can comment on any blog. Thank you. That was it as my internship work, and have a nice day.